Hello everyone, welcome to my channel. In this video, we will learn how to solve the UGC NET Computer Science previous paper of the year 2005 December paper 2. There are actually 50 questions in the paper 2. We will cover 25 questions in part 1 and the remaining 25 questions in part 2. I will explain how to solve this question in simple terms and provide tips and tricks to help you ace the exam. So whether you are a beginner or an experienced one, this video is for you. So let's start the video. So first question is, T is a graph with n number of vertices and T is connected and has exactly n minus 1 number of edges. Then T is a tree, T contains no cycles, every pair of vertices in T is connected by exactly one path, all of these. So they have given the T is a graph with n number of vertices. Let us consider this n number of vertices as 3. So we are considering the n value as 3. Okay. So T is connected. That means all the vertices in the T is connected and it has exactly n minus 1 number of edges. That means the edges must be here 2. N minus 1 is 2. Okay. So now let us draw a diagram here based on the given series. So we have 3 vertices and 2 edges. 2 edges. Right. So now it is a tree, right? So here T is a tree. So this particular graph is a tree. Tree now. Right. So all the edges, all the vertices here are connected and there is no cycle here. All the vertices are connected. And every pair of vertices in T is connected by exactly one path, right? So here the pair of vertices are covered by one path and this pair of vertices are covered by one path. So all these properties are satisfying, that's why the option is B. Next one. If the proposition negation P implies Q is true, then the truth value of the proposition negation P or P implies Q is dash. So from the proposition given here, negation P implies Q, so we can conclude that, so we can write P or Q. P or Q. So here P can be true or false and Q can be true or false. That is, nothing can be said about this value here. Okay. So from the given expression, negation P or P implies Q. So we can write the P implies Q as a negation P or Q. So negation P or Q. Okay. Negation P or Q. So now if you open the parenthesis here, then so negation, it will become negation P or Q. Okay. So negation P or negation P will become negation P. So negation P or Q. Since nothing can be said about the truth value of P or Q, it implies that negation P or Q can also be true or false. Hence, we cannot determine the values whether the P and Q are true or not. So, D is the correct answer. Next one. Let A and B be two arbitrary events, then which of these will follow? Generally, we know that P of A in B equals to P of A plus B, P of A plus P of B minus P of A intersection B. And A intersection B can be 0 or more than 0 when it is more than 0. Okay. So here the option A, that is the P of A in B equals to P of A into P of B is valid only if A and B are independent, which is not given here. And in option B, P of A in B equals to P of A plus P of B is also valid only if A and B are mutually exclusive events. So which is also not given in the question, right? And option D here. So option D is P of A by B equals to P of A in B plus P of B. The correct formula for conditional probability is P of A by B equals to A intersection B by P of B. Okay, so this one is wrong. So D is wrong. And A and B are valid, but in the certain cases. So in independent cases and in mutually exclusive cases. But if A and D are arbitrary events, then so C, option C is the correct one. So option C is the correct answer here. Next, which sentence can be generated by this given expression here? So S implies DR BA, A implies DR CCA. So let us consider the given expression as the 1 and 2. Okay, 1 and 2, equation 1 and 2. First of all, we will simplify the equation 2 here. So T2 here, right? So we will substitute A in the given equation itself. Then A implies DR CCA. So we can place the D, either D or CCA in the place of A. So CC whole star D. Right. So we have to substitute this value in the equation 1. So in the place of A, we have to replace this one. So S implies D bar B capital A. So what is the capital A value here? So so we can replace the A with D. So D or BD, or we can replace the A value with CC bar CC whole star D. So we will replace CC whole star D. So here in the given options, so option A will follow here because B, C, C, D is given in here, right? So that's why the A is the correct answer. Next one. Regular expression A plus B denotes the set. So which of the given sets the A plus B denotes? Regular expression A plus B means either A, so either A or B can be accepted. Only this can be written as A comma B. So answer is C, option C. Next one. Which of the following is divisible by 4? To determine which binary number is divisible by 4, we have to check the last bits here. If the last 3 bits are 1, 0, 0, then it is obviously divisible by 4. From the given options, only option A is having the last 3 bits as 1, 0, 0. So now option A is the only one which is divisible by 4, and the remaining 3 won't get divisible by 4. So we can easily find out the option here, or else we can convert the given binary number into decimal number and then perform the division by 4. Okay, so this is a simple task, right? So finding out the ending of 3 digits as 100. So option A is the correct answer. Next, a half adder is also known as. A half adder is a combination circuit used to add two binary numbers. It produces two outputs, that is the sum and carry. In the sum, the result is of XOR operation, and in carry it is in the AND operation. So sum will give A XOR B and carry will be A and B. Right. So the sum output is generated using an XOR gate and the carry output is generated using the AND gate. So it is the combination of two things. So answer is the XOR circuit. Next. Consider the following sequence of instructions. A equals to A XOR B and B equals to A XOR B, A equals to B XOR A. This sequence will result in which of the values? So let us consider A and B are some binary numbers. So A and B as some binary number. So I am considering the A value as So first, let us evaluate the first instruction here. So A XOR B. So we know that for A XOR B, the values are different, then the answer is 1. If the values are same, corresponding bits are same, then the answer is 0. So here 0, 0, 1, 0, 0, 1, 0 and 0. So now this is the new A value here, right? A value. Next. So B equals to A XOR B. So B equals to the B value is, we have to calculate the XOR of these two values, A XOR B. So then the answer will be, so 0 and 0, right? So 0, 1, 1, 1, 0, 1, 0, 1. So this is the new B value. Now A equals to B XOR A. Now again we have to find out the XOR of these two new values, A XOR B. So then the answer is 0, 1, 0, 1, 0, 0, 0, 1. Okay. So 1, 0, 0, 1, 0, 1, 0. So now if you check the given options here, so the answer is C. That is, we have swapped just the values of A and B, right? So here the A value, the new A value is 1, 0, 0, 1, 0, 1, 0, and B value is this one. Okay. So here the A value is 1, 0, 1, 0, 1, 1, 0. So now A value has been copied to B here, right? So these two are the new A and B values. So here if you observe, the A value is copied to B and B value is copied to A, right? So B is copied to A and A is copied to B. That means a swap of these two values are performed here. So that's why the option is the C, swap A and B. Next, consider the following circuit here. So to make it a tautology, the question mark should be dash. That is the question. So for this question, the given options are NAND gate, AND gate, OR gate and XOR gate. So in the question mark place, so we have to, so which gate we have to replace here to make it a tautology. That means the result must be, the F value must be equals to 1. To make it a tautology or true value, so what must be placed in the question mark? That is the question given. So let us substitute each and every gate given in the options. So first we will consider the NAND gate, right? So what is the expression of F? So here F equals to x plus y, plus, let us consider the NAND gate here, x dot y whole bar. So we are applying the, considering the NAND gate here. So if you open the parenthesis here, then x plus y plus x dash plus y dash. So now we both get cancelled here and the answer is 1. So now the result is 1. So here the F is here true. That means the NAND gate must be placed here. The correct option is option A. Next, when an inverter is placed between both inputs of an XOR flip-flop, the resulting flip-flop is, D flip-flop, this one. Next, what is the output of the following C program? Main, printf, %d, %d, followed by size of here. So first one is mentioned as float, and second one is the size of 3.14, and third one is the size of 3.141. So in the given C program, the size of 3.14 f, that is the float value. This expression calculates the size of the floating point constant 3.14 in bytes. So on most of the systems, floating point numbers are represented using 4 bytes, that is a 32 bits, right? So size of the 3.14 is 4 bytes. Next, size of 3.14. So here the 3.14 is it is a float value, right? 3.14, it is represented in the float value. So the size of the floating point result will also be 4 bytes. Next one, the size of the 3.141, similar to the first case, the C compiler considers this as a double value. So for which the double value size is 8. So the answer is a 448. Okay. Next one. The bitwise OR with the bitwise OR of 35 with 7 in C will be. To perform the bitwise OR of 35 and 7, first of all we have to convert the 35 into binary value. So the binary value of 35 is 1 000 11. The binary value of 7 is 111. So remaining will be zeros. So perform the XOR of these two binary bits. Then 0 0 1 0 0 1. So 1 0 0 1 00. Okay. So if you perform the bitwise OR and then convert these values into decimal format, then you will get the answer. Data members and member function of a class by default is respectively. Data members of a class are by default private, and also member function of a class are also by default private. So the answer is private. Next one. Function overloading done at runtime, compile time, linking time, or switching from function to function. Function overloading. Function overloading means it is done at the compile time, because before execution of a program, compiler decides the flow of the program, that is from which form will be used during runtime, like that. So the answer is B, compile time. What will be the value of I for the following expression? Int f equals to 11, I equals to 3, and I post int I equals to I plus equals to f greater than 3 question mark I and 2 is to 5. So this is a ternary operator, right? Ternary conditional operator. Okay. So I plus equals to means, so we have to find out if f is greater than 3. That is, if f value is greater than 3, if f greater than 3, then if it is true, then the I and 2 will follow, and if f greater than 3 is false, then 5 will follow. So I and 2 will follow only if f value is greater than 3, and 5 will follow only if it is false. So here the f value is 11, which is greater than 3. 11 greater than 3 is true. So that's why the condition I and 2 will follow here. Okay. So now I plus equals to I and 2. So what is the I value here? I value is 3. So 3 and 2. So if you perform the AND operation of 3 and 2, so 0, 1, 1, 0, 1, 0. So if you perform the AND operation of these two values, then the answer is 2 only. 3 and 2 is 2. Okay. So now I plus equals to 2. That means I equals to I plus 2. So I value is 3, right? So 3 plus 2, that is 5. I value equals to 5. It is the answer. So I value is 5. Option B is correct here. Next one. A schema describes. A schema is a complete description of a database structure that includes the data elements, records, files, and relationship between them. And this schema also includes the data elements, records, files, record relationship, etc. So that's why the answer is all of the above. The schema describes all of the above. Next one. One approach to standardizing storing of data. So which approach we are using to standardizing the storing of data? We are using the CODA-SIL, that is an acronym for Conference or Committee on Data Systems Languages. This was a consortium formed in 1959 to guide the development of a standard programming language that could be used on many computers. The effort led to the development of COBOL and other standards. So option D is the correct option. Next one. So we use this to store and organize the data in the databases, particularly focusing on hierarchical and network database structures. And if you want to know about the remaining options also, MIS means Management Information Systems. That refers to the systems for managing organizational information and not for storing data. And structured programming. It is a programming methodology and not a data storage. So that's why CODA-SIL is the correct answer. Next one. In a relational schema, each tuple is divided into fields called. So in a particular relational schema, each tuple means a row. Okay. So here the answer is domains. A domain is defined as a set of all unique values permitted for an attribute. For example, a domain of date is a set of all possible valid dates. A domain of integer is all possible whole numbers. A domain of day of week is Monday, Tuesday, Wednesday, like up to Sunday. So this in effect is defining rules for a particular attribute. So option B is the correct option. An embedded pointer provides. So what is meant by an embedded pointer? An embedded pointer is a reference or pointer stored directly in a data record. It is often used in network or hierarchical database models and provides the physical record key, inserted index, and secondary access paths. So embedded pointer is a pointer set in a data record instead of a directory. So all these options will follow here. That's why option is all of the above. A locked file can be accessed by only one user, modified by users with the correct password, used to hide sensitive information, both B and C. So file locking is a mechanism that restricts access to a computer file by allowing only one user or process access at any specific time. So option A is the correct option. It can be accessed by only one user. Right. Next one. In what tree, for every node, the height of its left subtree and right subtree differ at least by 1. So the option is the AVL tree. Correct option is AVL tree. Because AVL tree is a self-balancing binary search tree and it was the first such data structure to be invented. In an AVL tree, the heights of the two child subtrees of any node differ at least, at most by 1. So these two, left child and right child, will differ at most by 1 value. So if at any time they differ by more than 1, then we have to apply the rebalance. We have to rebalance the factor to -1. So we have to rebalance the factor here. So correct option is the AVL tree. Next one. A hash function f defined as f of key equals to key mod 7 with a linear probing. It is used to insert the key 37, 38, 72, 48, 98, 11, 56 into a table index from 0 to 6. What will be the locations of 11? So where the key location is, the key 11 will be placed in the memory if you are using the linear probing technique. So here we are using the key mod 7, the linear probing technique. So key mod 7, that is a 37 mod 7. So if you are performing the mod operation here, 37 mod 7, the option is 2. So it can be placed in 2. So we know that, right, how to perform the modulus operation. We have to consider the remainder of this 2. So 37 by 7 means the remainder will be 2. So 37 is placed here, and 38 is placed in 3. So remainder is 3, right? 38 and 72 is placed in the location, 4th location. So next one is the 48. So 48 mod 7. So 7 6 48, right? So it will be it is placed here in 6th location, 48. Now the next one, 98 mod 7. So now 98 mod 7. 98 mod 7 means it will be placed in 0. 98 is placed here in 0. Next 11 mod 7. So it will be placed in the location 4 actually. But 4 is already filled. That's why it will consider the next location, that is the 5. So option 5 is the correct one. C. Next one. Consider the graph which of the following is a valid topological sorting. A topological sort or topological ordering of a directed graph is a linear ordering of its vertices such that for every direct edge uv from vertex u to v. So if you consider the u to v, so here the u comes before v. So in the ordering, that means in the format of uv it will be denoted. So if you consider the diagram, given diagram here, so the edge, the direct edge is between the A and B, A and D, and B and C, B and D. So that means before B, A must come, and before C, B must be there, right? So BC must be there, and BD, and here AD, it must be there. So these 4 options must follow here, and 4 things will follow here in the option D, right? So here AB comes here, right? And then B follows D. This one is given, and D follows C. So this one is also given, right? So the option D is the correct one. Next one. The initial configuration of Q is ABCD. A is at the front. To get the configuration BCBA, how many deletions and additions must be required here? A Q is set up as in the FIFO rule, that is in the first in first out rule. So here it is showing that A is at the front part. That means, so first we have to delete the A value, and then B, and then C, and then D. So A is the first one in the queue, and A has to be the first one out of the queue. So if D has to be the first one in the queue, the 3 times that come in front of D have to be removed. So that's why there are 3 deletion of A, B, C, and 3 insertions of C, B, and A possible. Okay, so the answer is 3 deletions and 3 additions. Which traversal technique lists the node of a binary search tree in ascending order? In-order traversal of a binary search tree gives always the sorted order. So option B is the correct one. So this is first part of the paper 2. So in the next the remaining questions will be discussed in the next video. Thanks for watching the video.